Hello everyone, and in this video we are going to be introducing circuit analysis, and so we're going to be applying the laws that we've been learning in order to figure out unknowns in a circuit that we have. And so in this example I've got this little circuit right here that we know the resistance for, we know the voltage source for, and we know the current source for. However, we don't know what the voltage is across each of our resistors, nor do we know the currents. And so we have four unknowns, and so we're going to need to somehow derive four relevant equations that will help us fully define this system that we're working with. And so with that, we'll get started. And so the very first thing to make note of here is Ohm's law. And so with Ohm's law, it tells us that V equals IR. That's something hopefully we remember from high school physics. And so the key thing to make note of is, what does this intuition really mean? Is that if I took my multimeter and I had it on voltage and I put one end on one side of the resistor and the other end on the other side of the resistor, and I measured what would this value be. So this is what I'm going to call V1. And then if we did the same thing across the second resistor we have right here, this is what's going to be V2. Now, in addition to that, something that I don't know that I'm looking for is I1 and I2. And so I'm going to use light blue right here. So I1 will be the current that's flowing through resistor 1, and I2 will be the current that flows through resistor 2 in this diagram. So current is conserved as it flows through this resistor, but we're going to make note of here how we've got this node right here, and I'll call this node A. And so in our circuit right here, current coming in is getting forked between a path that leads through resistor 2 and another path that leads through the current source I sub S in this circuit. So let's start drawing some of these equations that we can start looking to in order to define our unknowns. The first one being Ohm's law. So what this really tells us is that generically V equals IR, but specifically it tells us that V1 is equal to I1 times R1. And it also tells us that V2, the voltage drop over resistor 2, is going to be equivalent to I2 times R2. And so the thing is that we know R1, R2, but we don't know any of the other variables in these two equations. So what we're going to do next is we're going to turn to Kirchhoff's voltage law, KVL. And so I'll try to use different colors here. What this tells us is that in a loop, the sum of all voltages has to be 0. So what that means is that in this loop right here between our voltage source, R1 and R2, the sum of these voltages has to be 0. So I'll just write V sub I must equal 0 right there. And so really what that tells us is that if we are adding in the voltage source V sub S and we are removing the voltage drop, or we're losing that voltage going over resistor 1, and then we're also losing voltage over resistor 2, that has to sum up to 0. So that is a key thing to make note of in our derivation from Kirchhoff's voltage law. And then finally what we have here is Kirchhoff's current law. And so what this guy tells us is that the sum of all currents at a node must equal 0. So the way I think about this is kind of similar to like a mass balance that a chemical engineer would do. And that means that basically whatever current goes into a node has to come out of that node, where we are conserving current, or charge is conserved. And so what this means is that if we were to zoom in on node A, so this will be node A, essentially what we have is a stream coming in, and that stream is going to be I1. So the current flowing through resistor 1, and then we've got a stream exiting, which is I2, that current flowing through resistor 2, and then finally we've got this other current here, and that is I sub S. And so if we do like a balance equation on this and we assume that there's no accumulation of charge at node A, what this really means is the following. So what we can write in this case is that I1 must equal IS plus I2. So whatever's coming in has to be leaving. That's all that says. And then we also have this following right here. So we would know, or we would have to know what V sub s is. We would have to know what I sub s is. But given that, in addition to these other unknowns, or these other defined variables, which would be the resistance on R1 and R2, then we could use these four equations to fully define and determine what the voltage and current is for R1 and R2 respectively. And so that is the intro to circuit analysis. The next step in this process is basically doing the algebra to isolate these variables. And so I can end this video here and I can make a follow-up where we basically just work through all this stuff. But I hope this helps, and thank you all for watching.